Hi, good evening, everyone. So, beta, in today's class, we are going to go ahead and understand what are random variables. सबसे पहले हमें statistics में ये जानना बहुत जरूरी है कि random variable होता क्या है. What is a random variable? A random थोड़ा definition पे ध्यान देते हैं. A random variable is any real number x connected with the random experiment E. So take an example. For example, bache, I go ahead and I tell you that E is a random experiment which is connected to tossing a coin. तो मेरा ये एक experiment है. What is my experiment here? My experiment is that I am going ahead and I am tossing a coin. इससे से related, I will have x such that this x represents the number of heads when two coins are tossed. So my experiment, जो मेरा experiment था, वो experiment क्या था? Tossing a coin. क्या था experiment बच्चे? What was my experiment? My experiment was tossing a coin. And what is my variable here? My variable is how many heads I get when I toss a coin or when I toss two coins. So this variable x, this is my random variable. इसी को मैं random variable बोल सकती हूँ. I can call this as my random variable. I can create another random variable y, and this y can represent the number of tails when two coins are tossed. तो जब दो coin toss होते हैं, what are the number of tails that you will be getting? That can be another variable, another random variable that I can create. I can have another random variable, say z, and I can say the number of times that we get head and tail equally when two coins are tossed. So I can go ahead and I can write any variable. मेरा experiment एक experiment. I have one experiment. I just have one experiment with me. What is the experiment I have with me? The experiment that I have with me is tossing a coin. I have created this experiment E. The experiment E is tossing a coin. Based on the experiment, I can go ahead and I can have different outcomes based on how I want to describe my random variable. So my random variable can be number of heads I get when two coins are tossed. It can be number of tails I get, or it can be anything else, right? So take an example. Let's take this example a bit forward now. So let's say that when I toss two coins, beta, what do I get? When I toss two coins, what can be my outcomes? My outcomes can be head, 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 tail, tail, head, tail, tail. So when I am tossing two coins, I am getting four possible outcomes out of it. Head, 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 tail, tail, head, tail, tail, right? Now, my variable x, it represented the number of heads when two coins are tossed. What is it representing? The number of heads when two coins are tossed. So, how many heads can you have? Beta, we can clearly see that we can have 0 heads. We can have 1 head. We can have 2 heads. So how many heads can I have? 0 head. How many times it is happening? 1 out of 4 times. How many heads I can have? One head. How many times it is happening? 2 out of 4 times. How many heads I can have? 2 head. How many times it is happening? 1 out of 4 times. And this is the probability of X. So this is a random variable because it takes different values. X is not stuck at one value. It is not the case कि X का value एक ही हो सकता है. X can only have one value. X can have different values with different probabilities. And due to this reason, we go ahead and we say that X represents a random variable. What does X become? X becomes a random variable. Am I clear with it? Okay, beta. So now let us try to go ahead and read this out. A random variable can be discrete or continuous in nature. Okay. So we can distribute our random variable in 2 parts. Discrete and continuous. Right? A discrete random variable is any random variable which is countable, like here. Number of heads can be 0, 1, or 2. It's a discrete random variable. A continuous random variable will take values in between this also. Like for example, my wait time to my wait time for maybe getting the next metro. My waiting time for the next metro. Okay, for the next train. Now this time can be 2 minutes. It can be 2.01 minutes. It can be 2.0001 minutes. It can be 3 minutes. It can be 3.5 minutes. So it is varying with integer values included. Therefore, it becomes a continuous random variable. What does it become? It becomes a continuous random variable. So a discrete random variable is anything which is discrete in nature. Discrete means it can only take integer values. It will only be countable. It can only take number values. It cannot take any of the decimal values. But continuous means it can take any value. कोई भी value ले सकता है. Am I clear with it? So random variable can therefore be distributed in 2 parts. It can be of 2 types, either discrete or continuous. Right? Let us take an example of discrete random variable. So for example, if I ask you, okay, give me the number that comes on the dice. So when you throw a dice, जब आपने एक dice को throw किया, you can get any of the 6 numbers. What are the numbers we can get, beta? We can get 1, 2, 3, 4, 5, or 6. So number 1, how can we create random variable out of this? So try to see this thing. So the first way in which I can create a random variable, it can be how, beta? It can be by saying that let X be a random variable and it represents the number noted when a dice is thrown. The number noted when a dice is thrown. So what will be the number that I note when a dice is thrown? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5 or 6. Isn't it? And each of them, what will be the probability associated with each of them? They will have equal probability of coming. So 1 by 6 in all the 6 cases. Right? This can be the first example. The second example of creating a random variable. Random variable is anything which is random in nature. Right? So X is also a random variable. and it represents the number you get on the dice. Now, if I just go ahead and I represent, say, y, which is a random variable, but now I am saying that y represents whether I see an odd number or an even number when a dice is thrown. And now I represent y by saying that let y is equal to 1 if even and 0 if odd. I've taken two values of y. Y can either be even or odd. Whenever you will see even number, when you throw a dice and you see an even number, then you will give the value of y as 1. And whenever you throw a dice and you get an odd number, then you will put the value of y as 0. So now, but here we see even number 2, 4, 6. How many cases? 3 cases out of 6 cases. So we can go ahead and we can make random variable y. So y can take the value 0 or 1. There are 3 parts where the number is odd. So the probability will be 3 by 6. And 3 parts where the number will be even. So probability will also be 3 by 6. It's random in nature. Why random? Because I am not certain. Sometimes it can go ahead and it can give me y as 0. Sometimes I can get y as 1. Half of the times I will get the value of y as 0. Half of the times I will get the value of y as 1. Right? So y therefore represents a random variable. Am I clear with it? Okay, beta. So this is an example of random variable. Okay. Now I want to do 2 properties with you. So properties. So beta, the first property that we want to see is that let's say x1 and x2 are random variable. We are assuming that x1 and x2 are random variable. Just for example, if I tell you x1 is number of heads when coin is tossed twice, and x2 is number seen when one dice is thrown. So x1 is a random variable. X2 is also a random variable. So my claim is that if x1 and x2, they are both random variable, then even when I multiply them with scalar quantity. So just say here I am saying that x1 was what beta? X1 was representing the number of heads, right? And the probability was written, I had gone ahead and written somewhere like this, the probability also. So even when I will multiply this random variable with some scalar quantity, मैंने इसको किसी scalar quantity से multiply किया, maybe I just keep the scalar as say 3 and I multiply throughout by 3. Then the new variable generated is also random variable, because ultimately, even if this is multiplied by 3, now getting 3 will have the probability 2 by 4. Getting 6 will have the probability 1 by 4. Getting 0 will have the probability 1 by 4. So when you go ahead and you multiply your variable with some scale, किसी scale से पूरे variable को multiply करते हो. When you multiply your variable with some scale, it still goes ahead and remains a random variable. It remains a random variable. Similarly, if you add 2 random variables, multiply 2 random variables, add them and multiply them with scalar, all of these are random variables, right? So scaling, let's write this down. Scaling a random variable keeps it as a random variable. Adding, multiplying two random variables keeps them as random variable. Right? So whether I add two random variables, whether I multiply two random variables, the new variable created, like for example, I create a new variable y1, which is x1 into x2, that will be random. If I create a new variable y2, which is x1 plus x2, it will remain a random variable. Right? So similarly, if I go ahead and I do like this, so suppose I tell you that x is number of heads when two coins are tossed, so 0, 1 and 2, and y represents the number on the dice when a dice is thrown. Now number on dice can be 1, 2, 3, 4, 5 and 6. Now I create a new variable z, and z is max of x comma y. So how many combinations I can create? Pehle beta, I'll pick from 0. So max of 0 comma 1, max of 0 comma 2, till so on till max of 0 comma 6. Then I will pick up the variable 1. So I will have max of 1 comma 1, max of 1 comma 2 and so on. I will go till max of 1 comma 6. Then I will pick 2 and I will take 2 with everything. So I will have max of 2 comma 1, max of 2 comma 2, and I will go till n, max of 6 comma 6. Right? This new variable will have some value. So max of 0 and 1 is 1, 0 and 2 is 2. So on, this will be 6, 1, 2, so on, this will be 6, 2, 2, so on, this will be 6. This new variable z that I have created, by taking the max values between x and y, this z variable will also be a random. ये भी random variable ही होगा. It will also be a random variable. So when you take max between x1 and x2, जब आप x1 और x2 का max लेते हो कि इन दोनों में maximum value क्या है? When you take min between x1 and x2, these are also random variables. Right? I want to do one last property. If x is a random variable, अगर हमारे पास x एक random variable है and f is a continuous function, हमने एक continuous function लिया है, then f of x is also going to be a random variable in nature. Take an example, beta. So I tell you, x is again the number of heads when two coins are tossed. So x ka value can be 0, 1 or 2. Now I create a function out of it. And what's the function I have created? The function I have created is y, right? And this function y is a continuous function. So to be continuous, we know that, suppose I tell you ki y is equal to 4x plus 5. This is a continuous function. It will be like this, continuous in nature. If I tell you y is equal to x square, this is also a continuous function. But if I tell you y is equal to mod x, then this is a discontinuous function. Sorry, it's still continuous in nature. It's a continuous function, right? It's not differentiable, it's continuous. It's also a continuous function. So try to see that but if I take, say, y is equal to greatest integer function, I'm not sure if you have heard of this, which is a step function, right? So from 0 to 1, it will take all answers will be 0. The moment it hits 1, from 1 to 2, all answers will be 1. So it's a discontinuous function at every number. So on this, I cannot apply the rule. So I am saying as long as my function is continuous function and x is a random variable, then f of x is also a random variable. That means if y is equal to 4x square, and x is a random variable, and I have created y as a function of x, and this is a continuous function. Of course, 4x square looks like this. It's a continuous function. So this y that has been created as 4x square, y will also be a random variable because it has been created as a function of the random variable, and x is a random. So if x is a random variable, y is a function of x, and this is a continuous function, then y will also be a random variable. Am I clear with it? Okay, beta, thank you.